Alright, this section is about trigonometric or polar forms of complex numbers, which is the first part of 10.4. So these 5 vocabulary words all correlate with one another. The real axis is a horizontal axis, or the x-axis. The imaginary axis is a vertical axis, or the y-axis. So we already know what these are, it's just that they're given different terms. And the reason for that is it helps us know how to graph such forms, and you'll see this soon. The complex plane is the coordinate plane in which complex numbers are graphed on. And these axes are used in the complex plane. These are what we call the axis. It's a regular coordinate plane, but we like to refer to it as the complex plane, and these two axes as the real axis or imaginary axis, because it helps us know how to graph these forms. So the two forms that are here are the trigonometric forms and the rectangular forms. The one you usually graph is a rectangular form, but the trigonometric form is really important because they do correlate with one another. Trigonometric form is r times cosine theta plus I times sine theta, or you could rewrite it as r times cis theta. The rectangular form is x plus yi, which is a much more simple form, and it's also known as the standard form. So the relationships among x, y, r, and theta is that x equals r, for one of them is x equals r times cosine theta, and y equals r times sine theta. The other two relationships are r equals the square root of x squared plus y squared, and then tangent theta equals y over x if x is not equal to 0. So how these are correlated, and to help you know why the real axis and the imaginary axis are called what they are, the imaginary axis graphs the y value. So y is being multiplied in rectangular form, is being multiplied with I, and it is which makes it an imaginary number. That means graphing the imaginary number on the imaginary axis would make sense. Also, the real axis is the horizontal axis, and x is not being multiplied by an imaginary number, which makes it a real number. This is why they have it as the real axis and imaginary axis. It helps you understand how to graph and what to graph where. But it's generally makes sense. You graph the x and the x and the y and the y, but imaginary and real help you understand it. And so these relationships, how they correlate with these two forms, is by looking at this, substituting x equals r cosine theta and y equals r times sine theta into x plus yi gives you this. So you substitute those into it, and it becomes the same thing as trigonometric form. The trigonometric or polar form of a complex number. The expression r times cosine theta plus I sine theta is called trigonometric form or polar form of a complex number x plus yi. So it's just restating how that form, this trigonometric form, is the trigonometric form of that standard form. So it's just showing how this is a more complex form, but it's a more detailed form as well. And r in this case is magnitude. It is the modulus or the absolute value of x plus yi. And theta is the argument of x plus yi. They're just two vocab words, modulus and argument. And modulus or absolute value are the same thing. So converting from rectangular form to trigonometric form requires three steps. Step 1 is to sketch a graph of the number x plus yi in the complex plane. Step 2 is to find r by using the equation r equals the square root of x squared plus y squared. And step 3 is to find theta by using the equation tangent theta equals y over x when x equals 0, when x does not equal 0, choosing the quadrant indicated in step 1. So this just shows you how rectangular form to trigonometric form is relatively harder than going from trigonometric to rectangular. But this is why you have 3 steps for it, and then you just use it, yeah. Alright, graph each complex number as a vector in the complex plane. So you have 7 plus 8i here. Rectangular form is x plus yi. So in this case, x is 7 and y is 8. So you go on the x-axis 7, 1, 2, 3, 4, 5, 6, 7, and then you go up 8, 1, 2, 3, 4, 5, 6, 7, 8. So right here is 7 for x and 8 for y, and you draw your vector going there, and that's how you graph that. Next one, another one, x plus yi. So for 5i, there's no x, so technically there's 0. You don't go anywhere on the x-axis, so you're just going to go up 5 because 5 is y. 1, 2, 3, 4, 5. and your vector will just be on the y-axis. Next one. -4. So x plus yi. Always know that. So if -4 is there, it's going to be plus 0i. So there's no I. So you don't go up or down the y-axis. You're just going to go to the left 4 because it's -4. 1, 2, 3, 4. And you're going to have your vector drawn on the x-axis. Over here, you have two different complex numbers. So what you do is you add like terms or subtract. So 6 minus 2 is 4. And then 2i minus 3 minus -3i. So 2i plus 3i is going to be 5i. So you have now x is 4 and y is 5. So you go to the right 4. 1, 2, 3, 4. And you're going to go up 5. 1, 2, 3, 4, 5. And that's your vector. Connect it and go from there. Alright, for these problems, find the resultant or sum of each pair of complex numbers. Express your answer in rectangular form. So this is just like the last graph we just did. You have two like terms, so write them out again. Because it says sum. So just add. Alright, like terms, you have 2 and -4, so it's -2. And then you have 3i minus I, because there's -I, so you have plus 2i. That's your answer. So let's do one more. 2 plus 6i, and then you're going to have plus -2i. It's just going to be 2 plus, and 6 minus 2i is 4i. Okay, next one. Find the modulus r of the number. 12 minus 5i. So to find r from the previous properties we remembered, relationships between x, y, r, and theta, you have r equals the square root of x squared plus y squared. And since we know x plus yi is rectangular form, we have x is 12, so r equals 12 squared plus -5, so y squared is going to be -5 squared. And so we have r equals 144 plus 25. R equals the square root of 144 plus 25 is 169. And so r equals 3 and 13. So for this one, same thing. R equals the square root of x squared plus y squared. And since it's x plus yi, we have r equals the square root of 11 squared plus -6 squared. R equals the square root of 121 plus 36. 121 plus 36 equals 157. And if you could simplify from there, but you can't, so that's your answer. Pretty, isn't 157, I think it's a prime number. So rewrite in trigonometric or polar form. So from the video notes, we had the 3 steps. So step 1 was to graph it as it is in rectangular form. So let's just draw that graph here. Alright, so we have the negative square root of 3 plus 1. So, oh, it's supposed to be 1i. Okay, so this is, we'll just rewrite it as negative square root of 3 plus I. So, again, x plus yi. So, if negative square root of 3 is x, it's going to be to the left. And so, when you graph these, square root of 3 is between 1 and 2, because square root of 4 is 2, so it's going to be below that. So we're going to have it like right here. And then we have I, which is 1. So it's going to be up here. So your vector is going to be going this way. And it goes from 0. And that's the vector for it. So now you have to do step 2. You have to find r, because remember, it's asking for trigonometric or polar form, and that's going to be r of cosine theta plus I sine theta, or r of cis theta. So for number 2, to find r, it's going to be the same equation as before, x squared plus y squared, square root of x squared plus y squared. So you have r equals the square root of negative square root of 3, negative root 3 squared, plus, and then y is 1, so 1 squared. R equals the square root of 3 plus 1. R equals the square root of 4, which equals 2. So if r is 2, now we have to do step 3, find theta. So tangent theta equals, it's another one of the relationships, y over x if x is not equal to 0. So in this case, let's just push it up here. Tangent theta equals y is 1 over, and then negative square root of 3. So for here, you have to realize that x is negative and y is positive. And so when you're thinking on the unit circle, x is negative and y is positive. When x is negative, it's on the left side, so it's going to be over here. And then when y is positive, it's going to be up here. So the only place this theta can be in is going to be in quadrant 2. So tangent theta equals, and you multiply, because you can't have a square at the bottom. Multiply by the square root of 3 over the square root of 3. Tangent theta equals, you have square root of 3 over 3, and it's a negative because of that. And so where is tangent theta negative square root of 3 over 3? So it could be in either quadrant 2 or quadrant 4, but because we had a negative x value and a positive y value, it's going to be in quadrant 2. So tangent theta equals, so where in quadrant 2 are we going to have a negative square root of 3 over 3 tangent? And that's going to be where 5 pi over 6 is, because if you memorize the unit circle. Or you could do sine over cosine. 5 pi over 6 would have a tangent of square root of 3 over 3. So now theta of 5 pi over 6 is going to be, so after you found out it was 5 pi over 6, that would be theta. So right now you have r, which is 2, and theta, which is 5 pi over 6. Or you could put it into degrees, which is, what, 150? So to write it out, it's r, remember, r cosine theta plus I sine theta, or, again, r cis theta. So we're going to do r cis, oh, I meant, yeah, 2 cis 5 pi over 6. Okay, next. Write each complex number in rectangular form. Give exact values for the real and imaginary parts. So over here, we're going to make cosine and sine into their value, and we're going to solve for them. So cosine of 60 degrees is 1/2, and then I, and then of sine of 60 degrees, which is square root of 3 over 2. So for the relationships we had between r, x, and y, because we need r, because trigonometric form is, we have r right here, and we have to solve for x and y in order to get it into rectangular form. Again, rectangular form, remember, is x plus yi. So we need x and y. For the relationships we had, x equals r times cosine theta, and then y equals r times sine of theta. So x is going to equal, since r here is 2, we're going to have 2 times, and then cosine of theta is 1/2, and sine of theta is square root of 3 over 2. For x, we need cosine, so we're going to have 1/2. And for y, we're going to have 2, same r, times the square root of 3 over 2. Solve for these. 2 over 2 is 1. And then 2 times the square root of 3 over 2. And it cancels out the 2's. It's going to be square root of 3. Final answer is going to be 1 plus the square root of 3. You had the I, so it's I root 3. Over here, same type of question, except there's no R. R is basically 1 in this case. So what we're going to do is we're going to solve for the cosine and sine again. So we're going to have cosine of pi over 6. Pi over 6, draw a unit circle, pi over 6 right here. So we're going to have cosine is going to be the square root of 3 over 2 plus I times sine of pi over 6 is 1/2. So to solve for x and y, again it's r times cosine of theta, then r times sine of theta. Solve for these. I have x equals, we have no r, so r is basically 1, times the square root of 3 over 2. Y equals 1 times 1/2. So these, without an r, cosine theta and I sine theta are going to be the same as x plus yi. So r is basically the difference between trigonometric form and rectangular form. So we're going to have x plus yi, because that's what it's asking for, rectangular form. And this is x, and this is y, because multiplying by 1. So it's going to be square root of 3 over 2 plus I over 2, because I times 1/2 is going to be I over 2.